is a video presentation for experiment 4, linear motion. The objective for this experiment are to investigate the relationship between force, mass, and acceleration. Second, to determine the acceleration of an object under a varying force. The apparatus for this experiment are a track rail, blower, pressure tube, gliders, flag, photo gates, messes, mess hanger, string, and pulley.
For the procedure of this experiment 4, first thing is the linear air track was assembled set as shown in figure 4.3. Second, switch on the pump and let the air blow through the track for several minutes, and then balance the track by adjusting the screws on the leg of the track so that the glider stays stationary and did not glide to either end when released. Third, one hook at one end and a flag on the top of the glider was inserted. 4. The mass of the hanger and the mass of the glider was measured and recorded. The length of the flag was then measured. 5. One end of the string to the hanger and the other end to the glider was attached.
Number 6. Mass of 20 gram on the hanger and 80 gram on the glider was placed. The string over the pulley was put. Next, the glider was positioned before the photo gate. The glider was released and recorded the time shown on the photo gate. Number 8. The process was repeated 2 more times to obtain the average time value. Number 9. The slotted mass on the glider was decreased by transferring a mass of 20 gram onto the hanger. Step 7 and 8 was repeated. Lastly, the procedure is repeated 3 more times, each time adding 20 gram from the slotted mass on the glider to the hanger.
And this is the results of our experiment. The length of flag X is equal to 9.7 cm plus minus 0.02 m. The mass of glider and flag M1 is equal to 0.0205 plus minus 0.10 kg. And the mass of hanger is M2 equals to 0.001 plus minus 0.10 kg. This is what we got for the analysis in where the graph shows weight force F n versus acceleration a meter per second square. As you can see here, the graph shows the weight force F is directly proportional to the acceleration a.
On the graph, we can conclude that the weight force F is directly proportional to the acceleration a. This means that as the force increases, the acceleration also increases proportionally. This relationship aligns with Newton's second law of motion, F equals to ma, where it represents the total mass of the system. For analysis 3, m is equals to F2 minus F1 over A2 minus A1 and is equals to 1.163 multiplied with 10 negative 3.
For analysis 4, we use the formula of total M is equals to total F over F plus total A over A multiplied with M. Thus, we get 4.337 multiplied with 10 negative 6. The gradient M represents the total mass empty of the system, which is the sum of MT1 equals to the mass of the glider, MT2 is equals to the mass of the hanger and slotted masses.
The answer for discussion 1, calculate the percentage difference between the gradient M and MT. What is the percent error in this experimental value? The gradient represents the total mass, which is the sum of the mass of the glider and the mass of the hanger with slotted masses. To calculate the percentage difference between the gradient and MT, we use the formula, which is percentage error equals to MT minus M divided by MT. We in the bracket and multiply by 100, and we will get the percentage error. Several factors could contribute to experimental errors. The first one is friction, in where the glider might experience friction with the track, which could lead to a lower acceleration than expected. Second is measurement inaccuracies, where errors in measuring the mass, time, or displacement could lead to incorrect values for force and acceleration. Lastly is air resistance, where the glider's movement through air could cause slight resistance, affecting the acceleration. To minimize the errors, for the first factors, we could use lubrication that can ensuring the track is smooth and well lubricated where it can reduce friction. Second is by improving measurements by using more precise measuring instrument. For example, digital timers, precise mass balance could improve the accuracy. The last factors, we can reduce the air resistance when conducting the experiment in a controlled environment, such as using a vacuum chamber or reducing the airflow. By using this method, it could help to mitigate the air resistance. Lastly, the conclusion for this experiment is the experiment achieved its objectives of investigating the relationship between force, mass, and acceleration and determining the acceleration of an object under varying force. The results validated that weight force, F, is directly proportional to acceleration, A, consistent with Newton's second law, F equals to ma. Experimental uncertainties included inaccuracies in time measurements and mass values, contributing to a percentage error between the gradient and the total mass. Errors were influenced by factors like friction, air resistance, and measurement limitations. In conclusion, the experiment successfully demonstrated the principles of linear motion.